The Leetcode problem 2684, maximum number of moves in a grid. So we are giving a grid, and it is a zero index m times n matrix grid. So it consists of positive integers. So we can start at any cell in the first column of the matrix. So for example, we can start at any cell like 2, 5, 3, and 10 because this is the first column of the matrix. Yeah. Now let's just continue. From a cell, row, and column, so we can move to any of the cells. So we need to understand where is the positions. So for example, from this cell 5, so we can go to row -1, column +1. So where is row -1, column +1? So this is our current row. So row -1 will be here, and column +1 will be here. Yeah. And next, row column +1. So it's gonna be here. And next, it is a row +1, column +1. It is here. Yeah. So this means for each of the cell, we can go to 3 directions, and we can go to this direction, and we can go to the right direction, and we can go to the bottom right direction. Yeah. So this means we can start for all the cells, and for each of the cell, we can go to 3 directions. Yeah. So such that the value of the cell you move to should be strictly bigger than the value of the current cell. But one we can move, so it means the value is strictly bigger than the current value. So for example, this 4, so for this number 2, 4 is strictly bigger than 2. So it means from 2, we can move to 4. Yeah. And for this 4, we can move to 9, because this is still a valid direction. And this 9 is strictly bigger than 4. And from 11, from 9, we can strictly move to 11, because in this direction, it is one of the 3 directions, and 11 is strictly bigger than 9. So how many steps? 1, 2, 3. Yeah, so there are 3 steps, so that is why we're gonna return a 3. So according to the explanation or the description about the problem, so we are very clear. It seems like a multi-source BFS. So what is a multi-source BFS? It means we're gonna start from a multi-source. Multi-source means we can start from multi-points, and then we're gonna start the BFS at the same time. It is like a parallel algorithms. Yeah, but in BFS, actually there's a sequence, but it is the same like a parallel. So we're gonna start here. This is a multi-source. After that, we're gonna continue to search, and the way is just like a BFS. We just need to check what is the longest path, and what is the longest path? It is here. So there are, yeah. So the longest path will be 3 steps. So from 2 to 4, 4 to 9, 9 to 11. So there are gonna be 3 steps. So we're gonna return a 3. And actually, there's a pattern for solving the multi-source BFS problem. Yeah, let's just use this kind of a pattern. So let me just prepare R and C. So I will always use R and C as my row and column. So it's going to be the length of the grid and the length of the grid 0. Now I want to check the multi-source. It means we're gonna start from the first column. Yeah. So I just need to use a for loop, because it's gonna be several rows, but it will gonna be the first column. So for R in range with capital R, we're gonna prepare a queue and weighted set. So this is going to be the weighted set. It's going to be an empty set, and the queue going to be an empty queue, because we're going to put something inside, and something will be the first column. Yeah. So for the weighted set, we're going to add a tuple. So the tuple will be the row and column. So the row going to be R, and column will be the first column. It's going to be 0. Yeah. And similarly, we're going to put the same thing inside of the queue. So queue should append R with 0, so this is the position, and I want to put a distance inside, because for me, I would like to use this kind of a distance to calculate it directly. So I'm gonna put a 0 first, because this is 0. After that, it's gonna become a 1, 2, 3, and finally, I just need to take out this distance and just take the maximum value of this distance. Yeah. Now the preparation is done. We just need to start the BFS. So how to start the multi-source BFS? We just need to check the queue. So while there's something inside the queue, we need to find the position. It's going to be RC, and with this distance, the distance is going to be D. And I'm going to pop it out from the left side. Yeah. Now I need to check a final result. So the final result gonna be the maximum of the result with D. Yeah. Because we're gonna check the longest distance, and this D will include all the possible distance, and we just need to take the maximum. So from here, I'm gonna prepare a result gonna be 0. Maybe the smallest value is just 0 because we are just checking the distance. Maybe the biggest for this example it is 3, and for this example it is 0. Yeah. Now we are going to search for the 3 directions, because this is just popped out the directions from this RC. For example, the first position. Now we are going to check the 3 directions. So let me just use a row and column. Yes, so this is going to be my new row and new column. So for, yeah, let me just use a tuple or not. It should be okay. So for row and column, inside the 3 directions. So where is those 3 directions? Let's just find the 3 directions. I'm going to use a tuple. Yeah, let's just copy those ones. Yeah, because basically it is just those ones. Let me write one by one. It's going to be here it is a row, but we're going to use r minus 1 and c plus 1. So this is 1, and another one is row and column plus 1, and the last one is r plus 1 and column plus 1. Yeah, so that's going to be the 3 directions. So it's going to be this row and this column. Now what we need to do is that we need to check the boundary, if it is inside the boundary or not. Yeah. So the row gonna check the boundary, and the column gonna check the boundary. We're gonna check the column boundary as well. Yeah. So if everything's okay, and we're gonna check the weighted set, and row and this column are not inside the weighted set, and still we need to. Yeah, still we need to check if the current value is strictly smaller. If the current value, this R and C, is strictly bigger than the previous value. Yeah, lowercase r and c. Yeah. So for this row and column, it should be strictly bigger than this R and C. Yeah. And it's gonna be easy. We just need to check this grid row and column. Gonna be strictly bigger than grid R and C. So if everything's okay, we want to put it inside the weighted set. So it's going to be with this row and column. And similarly, the Q going to append this new row and new column. And for the distance, it's going to be D plus 1. Finally, we're going to return the final result, because anyway, we checked the maximum value of this result. Yeah. Let me just submit it to check. As you can see, it works. Now let me just submit all testing cases to check. As you can see, it works, and it's pretty fast. Yeah, because this is just a multi-source BFS, and the time complexity is still m times n, because we used the weighted set, and actually we weighted each of the cell only once, and m times n going to be 10 to the power 5. That is why it is so fast. Now, what we're gonna do is that maybe we don't need to check the maximum. We just need to take out this value d. Maybe the final value gonna be this d, because the final value, this is just a BFS. So this d must be the maximum. Yeah, let's just try to use this way. Yeah, so for each of the time, we just assign this value to d, and we just return the result. And let's just have a check. As you can see, it works, but I prefer to use that kind of way, because I think that is even better for checking the longest distance. Or maybe we don't need to use the result, because finally, this distance d should always be the maximum value. Let's just return a d with the maximum distance, because if this is the last one, and the distance must be bigger, yeah, according to the BFS. As you can see, I believe it should work. Yeah, as you can see, it works. Yeah, so it always depends on what kind of solution you're gonna write, but each way gonna be right. We just need to understand this is a multi-source BFS, and we need to check the 3 directions, and then we're gonna need to check the boundary. If everything's okay, we put it inside the weighted set and cube as well. And finally, we just need to return the maximum distance. Thank you for watching. See you next time.